Today, we want to talk about customizing math instruction materials in multilingual classrooms. We know that English learners represent 10 to 20% of students nationwide, and they face persistent achievement gaps compared to native English speakers. Teachers spend a significant amount of time adapting math materials to make them linguistically accessible, and this adaptation compounds learning and confidence gaps.
In our local school district, Long Beach Unified, 16% of the students are classified as English learners. We've spoken to several teachers, and they'll express sentiment like adapting a text to facilitate language understanding is very difficult and time-consuming.
They also told us that they spend any time between 30 and 45 minutes for one side of a worksheet, and that it can become overwhelming. They know that English learning support needs to be intentional, differentiated, and personalized. Let's look at Mr. Valdepeña's classroom. He needs to teach systems of equations, and he has a classroom with 2 students. One is Bofa. She's at a WIDA level 1, which means that she has a minimal understanding and she can use phrases. She also has, Mr. Valdepeña also has 1, and he's at a WIDA level 3, and he's increasingly showing independence and the use of sentences. He also knows that direct translation can hinder fluency.
Stanford Education Research has actually created a curriculum design principles and a framework to be able to translate math curricula, especially for English learners. We're going to take advantage of that. There are activities that they call math language routines. One of these is called an information gap card. These cards allow teachers to facilitate structured conversation between pairs of students to be able to solve a problem collaboratively. It's simple to state, but it's actually quite time-consuming to implement. So let's see if we can use an off-the-shelf LLM like Google Gemini to be able to help us do this. So here we have a video demonstrating this prototype. We can prompt Gemini to say we're an 8th grade teacher teaching English learners and describe the information gap activity. It actually gives us some example problems and tries to actually create this conceptual structure of a problem card and a data card without actually producing usable cards themselves.
We can further prompt the LLM to use an image generator and also to create visual cards. We can ask it to shorten sentences and to simplify tenses.
So our adaptation playbook is focused initially on middle school math. We focus on this crucial stage of development because we know it's a predictor of future student success. We're going to leverage research-proven curricula design principles designed for English learners and off-the-shelf LLM-agnostic prompts that we can help teachers be able to implement these activities. We also have a teacher-in-the-loop assessment approach that allows us to further personalize based on a student's language proficiency. We have an example of a problem card and a data card. If you remember our student Bopa, she had a WIDA level 1. So we can actually have further personalization that a teacher can prompt the LLM with using prompts from our playbook to be able to simplify the card that would be more appropriate for Bopa.
Funding will support the next phase of validation. We will co-design with experienced middle school teachers to refine, stress test, and document their knowledge from the classroom. We will run a workshop with LA's middle school teachers at Pomona College, and we'll formalize the insights into an LLM agnostic playbook so that it can be adapted at scale. We want to capture fitness, we want to promote AI literacy, we want to reduce the risk aversion that we heard from the interviews we performed, and we also want to use this time to evaluate usability and time savings.
So our vision from pilot to platform begins with the phase 1, which has 2 main value propositions. One is to save teachers valuable time to do what they do best, which is instruct, assess, and mentor their students, to be able to use off-the-shelf LLMs in our curated playbook to generate materials. The second is to reduce choice overload. Teachers have choices between hundreds of potential instructional activities. We're going to curate these to a dozen or so based on educational research that we're bringing to the classroom, in addition with best practices that we'll infer from expert teachers through our co-design phase. In phase 2, we want to be able to create a web application to implement our playbook and potentially an algorithm to further personalize 1 or 2 activities based on the math lesson at hand and previous teacher assessments from the curated dozen in phase 1. In phase 3, we think of that as our scaling approach to scale from middle school math to other grade levels and potentially other subject areas in the future.
Here is a quick timeline of what we described. In each of the milestones, we plan to have a check-in with our advisor, Tammy Kwan. I am a parent and of 2 daughters, and I'm also an immigrant. I've experienced what it's like to simultaneously learn content and a new language. I'm a mathematician by training, and I am an AI policy fellow at the Princeton AI Lab, where I work with the state of California to advance AI literacy and the responsible and secure adoption of AI.
Aisha and I both have a passion for mathematics. We, in fact, started a math circle to be able to get kids to really understand the joy of mathematical thinking. We think it's crucial that all kids have the best math quality education. Our professional work in the AI field, whether it be through policy or technical development, really makes us the right team to implement this project. Thank you so much for your time.